So I was a Minecraft kid, and all my friends were Minecraft kids. And what do you get when kids are together? Yep, a Minecraft server. And as a kid with little to no knowledge, I searched through many YouTube tutorials on how to set one up, video after video, and one thing became very clear. Hamachi. Hey, but what's wrong with it? What's wrong with Hamachi? Well, as a kid, I always wondered, how did the public Minecraft servers do it? How did they have a 24/7 uptime and didn't require Hamachi to connect to them, just their IP address? And that's when I learned about dedicated servers and port forwarding. Now with a dedicated server, you can leave the machine on 24/7, have hardware fully committed to running your server programs, and connect to your services from one domain. Oh, and you can flex on nerds. With Hamachi, it's running on your main machine, which typically isn't on 24/7. You would also have to split computer resources to your server. Oh, and everyone must have it to connect. So why didn't Minecraft Kid Me create a dedicated server? Well, it came at a cost. And last time I checked, kids didn't get server hosting allowances. And even creating one I lacked the technical skills for with my small baby brain. So just like that, I would have to concede to Hamachi, with making dedicated servers being one of my Minecraft kid dreams. So I'm an adult now, with adult money, and recently I managed to find someone selling this used office computer. One of the main reasons I picked this up specifically was because of its form factor. As you can see, it's tiny, while also having decent specs, which I will show later on in the video. So converted, this sent me back about $150, which is hefty, but honestly for what I get, I would say it's very affordable. However, this poses us with a very difficult dilemma. Buy a $150 machine to become a dedicated server that runs everything from websites to game servers and beyond, or 15 minutes of CS case openings. Okay, so it's been about 15 minutes. Let's take a look at the specs here. So the machine has an Intel i5-10500, having 6 cores and 12 threads, ideal for something I would want to run a few game servers on. For memory, it has 16GB of DDR4 RAM, which is on the lower side considering how fast RAM usage can stack up, but it's good enough. Another observation to make is the machine's OS is Windows 11, but I'm planning to switch this to Ubuntu server. Coming back to the machine, I flashed this USB drive with the Ubuntu server OS, and will be entering the machine BIOS to boot from it. I used Bellina Etcher to flash the USB with the OS image, which was recommended on the download page of the OS. Now that we're in the system BIOS, which was done by spamming the F10 key during startup, we want to look for the boot options. From here, we want to set the boot priority to be our USB first, so that the machine will boot from our USB, which is our desired OS. As we wait for the OS to boot up and load to the setup, allow me to explain what's the game plan from here, and some network fundamentals for your learning pleasure. This is a router. This is your home router. Most modern day routers come with DHCP, which automatically assigns an internal IP address to devices that connect to it. Think of it like a hotel receptionist, where she automatically gives you a room number. One thing to note is the lease time, which is the amount of time the internal IP address is allotted to the device before they have to renew the lease. And even after renewal, they are not promised the same IP address. To combat this, we can configure the router to preserve certain IPs. All it needs is the device's MAC address, which is its unique identifier. For port forwarding, I'll give it to you guys oversimplified. Picture a locked door. Behind it is your home network. When you port forward, you expose a port, which external machines can access through the internet, kind of like adding a doggy door on the locked door. We do this so that your friends on their other networks are able to connect to your home network through this doggy door. Okay, now back to the router. Your home router. Your ISP gives your home network router a public IP address, and typically for a home setup, this is a dynamic IP, meaning sometimes it can change up on you, like my ex-girlfriend. So how do we handle a dynamic IP? Your friends will have to constantly be updated of your current public IP to connect to you, as they won't be able to connect with the old ones. Well, this is where a dynamic DNS or DDNS comes in. It acts as a domain which your router can reliably update its IP address to, so that this DDNS is constantly pointing towards your current public IP. Okay, enough nerd shit. Let's look at the Ubuntu installation progress. Oh, let's just reinstall this. Alright, and if you're trying this at home, I highly recommend during the setup that you enable OpenSSH, as it allows remote access to the terminal of the machine. Okay, we finally got it set up on the second try, and the first order of business is to find the MAC address of the machine's Ethernet adapter. We will be reserving an internal IP for this specific MAC address. Okay, after finding a MAC address, this is what the settings look like on my router config page. Yours may look a bit different, but you should be able to find something similar. But now I've assigned an internal IP of my choosing to it. With that, we should now be able to SSH into the server on the machine in the same local network.
Weird. We'll have a look. Of course we'll have a look.
An important note to make here is, as I have reserved the Ethernet's MAC address specifically, be sure to connect it via Ethernet to your router to ensure that you get the intended internal IP address. Here is my server set up next to my router connected via Ethernet. Ignore the wiring. So we're pretty much in the last stretch. Firstly, let's open a port, where we'll do some testing to see if our server works later. For the external and internal start and end ports, I typically just keep it the same. So for this example, all of it would be 8080, and it will use the TCP protocol, as I'm testing it on a hosted website. However, for game servers, you may have to look at the documentation, but for most of it, it recommends using both TCP and UDP, which is an option that is given. For Minecraft, it's on the port 25665, so if you're planning to host one, forward that port. So now let's create a dynamic DNS. I'm using no IP as they provide one free hostname and you just have to make an account. Now pick a nice hostname for yourself, it can be anything, and choose a domain from the drop down list. I'll keep the record type the same and the blacked out part would be the public IP address field. For that, I would also leave it as is, as that is automatically filled up with your public IP. Once you're finished setting that up, no IP will show you window instructions and will also give you a key username and password. This is to fill in the fields for your router's DDNS config. Click save and apply, and the status should show something along the lines of success. And just like that, your router is now pointed towards your no IP DDNS. And yeah, that's basically it. All that's left for us to do now is to have a service at port 8080 and to check if it is accessible. So here I've made a basic website to service at this port, and all that's left to do is to try to access it from an external device. Notice that I am launching it on the port 8080 as it is what I forwarded earlier. Now I'll transfer this file over to my server and I'll launch it over there. Alright, I'm on my phone, and I'll test if the DDNS and port is working. As you can see, I'm on mobile data to ensure I'm no longer connected to my local network. And just like that, I can successfully resolve my server and port, and I'm now able to view my website from an external device. Finally, I am now free from the shackles of Hamachi, and so can you. I hope you have been able to learn something from this video and use the knowledge passed on to you to create your very own dedicated server. I plan to host a Discord bot and a Minecraft server soon, so if you require a guide or need help with anything in this video, drop a comment. Oh, and do try this at home. That's it, take care.